Hello, today we're doing lesson 9.7, quadratic systems. A quadratic system is a system of one or more conics. You can use graphing, substitution, and elimination to solve these systems. I'm going to show you all three today. If the graphs in the system are aligned in a conic section, the graph can intersect in 0, 1, or 2 points. So these are examples below. If I have a line in a circle, the line doesn't have to be going through it. It can, it doesn't have to be. That would just be one example of no solution. This would be an example of one solution where the line is just touching the figure in one spot. And this would be an example of two solutions where we would have two answers. So what we're going to do is we're going to go ahead and solve this by using your graphing calculator. Now, you know in order to put into your graphing calculator, you should get y all by itself. So in this first problem, or in this top equation, let's go ahead and add 7x to both sides. Y squared plus 3 equals 7x. Now we're going to go ahead and subtract 3 on both sides. So we get y squared equals 7x minus 3. Now we want to get y all by itself by square rooting both sides. Now remember, when you put in a square root, you get two answers, a plus and a minus, and then we're taking the square root of 7x minus 3. So how would you graph this on your graphing calculator? On your calculator, you are going to have to put it in as two equations. You're going to have to do y equals the positive square root of 7x minus 3, and then you're going to need to do y equals the negative of the square root of 7x minus 3. Now, we're going to go ahead and take this equation and get our y by itself. So we're going to subtract 2x on both sides. When I do that, I get negative y equals negative 2x plus 3. Y is almost by itself, but we need to get rid of the negative. So I'm going to multiply everything through by a negative 1. And when I do that, I get y equals 2x minus 3. So this is our third equation that we're going to go ahead and put into our calculator. So I want everyone to take your calculators, and I want you to put these three equations into your y equals screen. Now, look what happens when I do that. I'm going to go ahead and erase this. Look how I put it in. I put in a square root, the parenthesis pops up. I made sure I put the 7x minus 3 inside the parenthesis, close it. Now here I had to put a negative in front of it, not a minus sign, otherwise you'll get an error, a negative. Same thing, and then I did 2x minus 3. And then you want to remember to go ahead and hit zoom 6 so that it puts your window back to normal. Now sometimes on these problems you may need to change your window. If you can kind of tell that there's going to be another intersection point or an intersection point at all and you can't see it. Okay, so here I can see there's going to be an intersection point here and here. So now what we're going to do is we're going to go to second calc, second trace, and we're going to go to intersect, number 5. And it's going to ask you for the first curve and the second curve. So let's do, the first one is our positive. Okay, we'll do this one first. So it's telling you what equation the cursor is on. So I'm okay with this, so I'm going to hit enter. Now I want it on my line. So I don't want it on, let's see, hold on. No, I don't want it there. See, I'm playing with the arrows. So I got my first curve, hit enter. Hold on. I don't know why the enter is not working. I'm waiting for it to ask me for my second curve. Okay, I know what happened. So I think I needed to see the cursor. So I arrowed to the right a little bit, then you can hit enter. There we go. Now it's asking for the second curve. So I want the line, because I want the intersection of the positive, the positive part, and then the line. So I'm going to look and wait till I see my equation for my line. No, there it is. So hit enter. Hit enter again, it guesses. And there you go. Your first intersection point is 4, 5. Now I'm going to go ahead and do it again for this bottom point. So this is the negative. So let's go to second trace, 5. Now I don't want the positive one, so I'm going to, there we go. The negative's good, hit enter. And I want it with the line, hit enter. There we go. And 0.75 and negative 1.5. There we go. Those are our two intersection points. Okay? Now, let's go ahead and do a problem where we are going to do substitution. All right, solve by substitution. This one is set up perfectly for substitution, so I'm going to go ahead, take this, and substitute it in for y. Now, when I do that, I get x squared plus y squared. I'm putting this in for y, so I need to do negative 3x plus 10. Since I have to square it, I know I have to FOIL it, so I'm just going to go ahead and write it out like this to save myself a step, and then it equals 10. So what you need to do is you need to FOIL this out, and then we're going to add our like terms, and then we're going to subtract 10. So when I FOIL this out, I go ahead, I leave my x squared alone. I get 9x squared minus 60x plus 100. And then I'm going to subtract this 10 over. So I'm going to subtract 10 equals 0. Now I'm going to go ahead and add up my like terms. When I do that, I get 10x squared minus 60x plus 90 equals 0. Then I'm going to go ahead and take a 10 out, or you can divide it out so it's gone. And then we're going to go ahead and factor. So what multiplies to give me positive 9 and adds to give me negative 6 is x minus 3, x minus 3. You don't need to write the answers twice, you're just writing it as 1, so x equals 3. Now it's part of our point, so now we have to plug it in, and we have to find out what y is. So when I plug it in, I get negative 3 times 3 plus 10, I get 1. Now, that's your answer, is 3, 1. Now, if you would have taken this and plugged it into the top equation, you would end up with two answers. You would end up with a plus or minus 1. But the problem is, if you take the negative 1 and test it into the second equation, it doesn't work. So we don't have two answers in this problem. We only have one. All right, let's try another one so you can see how substitution works again. Okay, this one is not set up for substitution, but I can see this y, I can get it all by itself. So I'm going to do y equals 3x plus 6. I'm going to take this and I'm going to substitute it into here. When I do that, I see that I have to square it, so I'm going to go ahead and write it twice. 3x plus 6, 3x plus 6, plus 24 equals 0. Okay, go ahead and FOIL this all out, add up your like terms. I'm just going to show you what I get because I want to show you something that happens on this problem. So we get 9x squared plus 44x plus 60 equals 0. Now, I look, there's no GCF that I could take out, so I'm thinking, okay, I have to do the log method of factoring. So 9 times 60 is 540. There are no factors that are going to multiply to give me a 540 and add to give me a 44. So a positive 44. So there's no solution. If you try the quadratic formula, you would get imaginary solutions. So imaginary solutions don't appear on our xy coordinate plane. So the answer to this system is no solution. There are no intersection points between the two figures. Okay, here you can go ahead, pause the video, and try the U-try. Now, coming up to the last type of problem, we can have, if the quadratic system is two conic sections, there can be 0 to 4 points of intersection. So we can have a ton of different solutions here. So here we're going to go ahead and use elimination. Okay, the way it looks right now, I can go ahead and just add my two equations together because my y squareds are going to cancel out. This is going to end up working out nicely because I will only have x's left. When I do this, I have 10x squared minus 90x plus 200 equals 0. You can either factor a 10 out or divide a 10 out, and when you do that, you're left with x squared minus 9x plus 20 equals 0. We can do simple factoring because what multiplies to give us a positive 20 and adds to give us a negative 9 is negative 5 and negative 4. So we have two answers here. We have x equals 5 and x equals 4. So we have two x's we need to plug in. You can plug it into whichever equation you like, but obviously the bottom one looks a little bit easier. So I'm going to go ahead and take my 5 and I'm going to plug it in. So when I plug it in for x, oops, I want to do the bottom equation. I just said that. So when I plug it in for x, I get 5 squared, which is 25, minus y squared, minus 16 equals 0. When you get the y squared all by itself, you end up with y squared equals 9. So you're going to get two answers here. You're going to get a plus or minus 3. Now, we're going to have to take our 5, and we're going to have to make 2 points. So we're going to have a solution that's 5, 3, and 5, -3. Now we're going to go ahead and plug 4 in. So when we plug 4 in, we get 4 squared, which is 16, minus y squared minus 16 equals 0. This is going to give me y squared to equal 0. So when I square root both sides, I only get 0. You can't have a positive or a negative 0, so this answer we only have 1 point. We have 4, 0. These are the 3 intersection points to this problem. Now, I do want you to pause the video and I want you to try the U-try on your own. I put a simple U-try. If you look at it and you go ahead and just start elimination, look what happens. This cancels and this cancels. So you end up with a problem where you don't even have to factor. You're going to end up with 2y squared minus 8, and you're easily going to be able to solve for y. Then take your y's, plug it back in, and find your x. It is really important in this section that you practice solving systems all 3 ways. We are going to have a mini quiz where you're going to have to do one of each type of solving a system. If you have questions, comments, or concerns, go ahead, write it at the bottom of the paper, and I'll see you.